Okay, so we're going to be talking about inelastic collisions. To introduce the topic in general, the overall goal of our experiment was to basically take two types of balls, a bouncy ball and the racquetball, and to see which one bounced higher throughout a certain period of time. The more kinetic energy that is conserved within a certain type of ball, the closer the ball will come to its original height when it is bounced. That is referring to an elastic collision, and the point of this experiment is to be measuring inelastic collisions. So we're going to be measuring when the ball is dropped, we're going to be measuring how far it comes back. So obviously we know that the balls, once they bounce, it's going to be an inelastic collision because they're not going to be dropped to the same height as they come up. And the main point of why we perform these experiments in general is because of the fact that inelastic collisions happen commonly throughout life, such as in photosynthesis and car accidents. And as a result, in the experiment, the racquetball overall bounced higher than the bouncy ball throughout a certain period of time. So we can conclude that the racquetball has a much more high elasticity rate.
All right, for our models, first let's talk about Newton's second law, which is force equals mass times acceleration. This means that force is dependent on how fast or slow an object is accelerating and how much mass an object has. Mass is not to be confused with weight, as weight is gravity times mass, which, I mean, that can change from planet to planet or where you are in the atmosphere, and we are obviously not talking about that. Energy conservation means that energy can never be created nor destroyed. It can only be transferred to outside systems. For example, in this experiment, we see both balls bounce closer and closer to the ground after the initial bounce. This is due to energy being transferred to the environment or around it, such as by air resistance or through friction to the ground. For our system schema, you can obviously see that there's the Earth, which obviously has gravitational influence on everything and is in contact with everything at a given time. The balls, which are influenced by gravity, and that's how we got our kinetic energy values, and are also in contact with everything. The person, which initially pushes the ball off the table, and the table, which is the starting point for the ball.
So for the experiment, what we did was we had two balls, ball A and ball B. They were positioned 0.75 meters off the ground onto the table. And so what we did was we rolled the ball off the table and tracked its bouncing. And so what we did is we looked at the X and Y positions with respect to time, and we repeated the experiment with ball B. So we used the Y values that we used from Tracker to determine the relative elasticities. In the cases of balls A and B, ball A has higher Y values than B, meaning that it bounced higher after the initial bounce in ball B, so that has more elasticity. And this is because more momentum is conserved, so the ball bounces higher. And so some of the results here, after the initial bounce, ball A bounced 0.5 meters off the ground and ball B bounced 0.42 meters off the ground. So then we used this to determine the percentages, and ball A bounced 62.5% of its initial height, and ball B bounced 52.5% of its initial height. And so we determined that there is a 10% height differential here, meaning that the racquetball retained 10% more kinetic energy it started with when it fell off the table with respect to the green ball. And then potential limitations, there are differences in air resistance, differences in mass of the balls, and then we had to repeat a couple trials because the balls deviated from the path a couple times, so we needed to make sure that it went in a straight line after bouncing off the table.
Right, for the physics involved, energy and momentum conservation were two of the biggest concepts that we use. Our goal was to determine which ball retained its momentum, and while looking at the momentum conservation was also to help. It also helped look at energy conservation since momentum is a derivative of kinetic energy. And as we can see, like the racquetball conserved 10% more energy than the green bouncy ball. And if we were to assume, one way this wouldn't make sense is if we were to assume this is like a problem in class where all the energy remains inside the system and we have to solve for one value. However, we know in the real world this isn't how things work. For example, in this system, or for this experiment, we lose energy to friction when the ball hits the ground, or when it moves through the air, it encounters air resistance, which also takes away energy from that system and transfers it to the air and the ground. Other factors that also likely impacted the energy and the momentum are things such as chemical composition and other things that impact elasticity through like the chemical composition, which we did not know for these.